Hey there, and welcome to BridgeText.com's tutorial on how to generate z-scores. Now, if you know anything about statistics, a z-score is a number that gets assigned to each value in a normal distribution to signify how far away from the mean it is. So let's take an example. Let's assume that we have a variable IQ. The mean is 100 and we know that it's normally distributed. It's designed to be. Let's say that the standard deviation is 10. Okay, so then the mean IQ of 100, the z-score is 0 because that's the mean. 110 has a z-score of 1 because that's 10 points or one standard deviation above the mean. An IQ of 120 would have a z-score of 2, and that works in reverse as well. So if you were dealing with an IQ of 90, that would have a z-score of -1, and 80 would have a z-score of -2, with 80 meaning you are 2 standard deviations below the mean at that point. Now, what we want to do is show you how, if you are dealing with a normal distribution in R, to automatically create z-scores for each value in a data set. Now here, I already kind of know, I've kind of cheated, I'm going backwards. I am using the rnorm command to create 10,000 values of IQ with a mean of 100 and standard deviation of 15, which actually I believe is the standard deviation for IQ, which again is also normally distributed variable. I've used the rounding function so that I don't have to deal with any, anything other than whole numbers. And then I've got the mean of IQ. So that was pretty successful. I wanted a mean of 100 and I ended up with 100.17. I'll take that. And standard deviation of 14.9. So using the R norm worked pretty well. It's close enough to reality that I would want to work with that. Now, one thing that we can do right quick is we can use the histogram command and just make sure, just visually see that we are looking at a normally distributed variable, which we are. That's pretty textbook bell curve right there. So we could work with that. You could go ahead and use something like a Shapiro-Wilk command if you just wanted to make absolutely certain that it was normally distributed. Here, I'm not going to do that because I've taken every measure to make sure that it is, but just in case, if you're working with something, you're not sure it's normally distributed, should you go to the effort of generating a z-score, just run a Shapiro-Wilk test or maybe a Kolmogorov-Smirnov test, just a test of normality before you proceed with something like that. Now, I am going to show you, I'm not going to show you the whole 10,000 item data set, but I'm going to show you the code to create that z-score. All right. So I'm starting out with just something called IQ mean, which is the mean of IQ, which again I know is pretty close to 100. I'm creating another variable to capture standard deviation, which is 14.9. Z is the name I'm assigning, not surprisingly, to my z-score variable. And how am I calculating that? Well, I'm subtracting IQ mean from IQ and dividing by standard deviation, which is exactly the definition of a z-score. And then I'm going to create a little data frame here that has, I'm going to call it IQ data, that has both IQ and the z-score in it. And then I'm going to show you the first 20 values of that. And we're going to sort of check it. All right, so here, for example, just theoretically, if you remember, 115 was supposed to be a z-score of 1 because with a standard deviation of 15, 115 is one standard deviation above the mean of 100, and we got pretty close. We got 0.93. Just this passes the smell test because anything below 100 has a negative z-score, which is what we would expect, and anything very, very close to 100 would have a z-score of about 0. I've just done a head. I've used the head command to show you 20. So I didn't quite have a value precisely of 100. But, if I said something like, let's say, 100, I could do that. And then I could just scroll through here too and just see if am I really close to 100 in any of these cases. I am. Look, here's 99, and that's pretty dang close to zero. So again, this mimics those properties really well. Oh, here's 100 exactly, and again, notice how close that is to zero. Now again, notice that this did not work out perfectly because this is mocked up data. I had 10,000 instances here. Now, if I'd made this a million or 10 million or 100 million or whatever, obviously I'd get a lot closer asymptotically, right, to 100 mean and 15 standard deviation. But that's still pretty good. And, in real world data, you're not going to get an absolutely perfect normal distribution. But if it is close enough to normal by something like the Shapiro-Wilk test, then this is the code. I'm going to highlight it for you again that you can use, and you can grab this off the bridgetext.com statistics blog too. You can use to handily create a z-score for every single value. And imagine if you have thousands, how cool it would be to just generate them automatically like this.